The groundbreaking discoveries made by the James Webb Space Telescope have left astronomers stunned. Rather than simply enhancing our understanding of the cosmos, Webb's observations are exposing a troubling reality. Our current knowledge of cosmology falls short when it comes to explaining the early universe. The long-standing Big Bang theory, once considered the cornerstone of cosmic origins, is now being seriously questioned. New models of creation may soon be necessary. But why is this once widely accepted theory now facing growing criticism? And more importantly, what could possibly replace it? Stick with us until the end as we explore this captivating mystery. Even those with only a basic interest in space science have likely heard that everything began with the Big Bang. But what does that really mean? How exactly did the universe come into existence? And how can we know any of this happened nearly 14 billion years ago? Despite common misconceptions, the Big Bang wasn't an explosion within space, it was the expansion of space itself. Roughly 13.8 billion years ago, time, space, and matter all emerged simultaneously from a state of unimaginable density known as a singularity. This singularity refers to a point of infinite density, temperature, and curvature of spacetime, a state where the known laws of general relativity break down. But how do we know such a thing exists? Scientists point to one key property the universe has had since its very beginning: it's expanding. Interestingly, this realization is quite recent in the grand scope of history. Less than a century ago, Edwin Hubble demonstrated that the Milky Way is not the only galaxy in the universe, and that other galaxies are actually moving away from us. This groundbreaking discovery shattered the long-held belief in a static and eternal universe. However, it's not that the cosmos is expanding into empty space, it's space itself that is continuously stretching. When this expansion is traced backward, scientists can calculate a point in time when matter and energy were infinitely dense, and all distances between points were essentially zero. This moment marks the beginning of everything, the Big Bang. One of the strongest pieces of evidence supporting this theory is the discovery of cosmic microwave background radiation, an afterglow of the universe's explosive origin. This faint radiation is a remnant from about 380,000 years after the Big Bang, during an era known as the recombination epoch. Remarkably, it still permeates the entire universe today. However, it's important to clarify that the Big Bang theory doesn't explain the exact moment the universe came into existence, it focuses instead on what happened immediately afterward. Specifically, scientists study the timeline beginning with what's known as Planck time, roughly 10 to the power of -43 seconds after the Big Bang, up to about 400,000 years later. While we have no insight into what the universe looked like before Planck time, the Big Bang theory remains a foundational pillar in modern cosmology. That's why things become especially intriguing and perplexing when researchers encounter evidence that challenges these well-established models, even prompting some to reconsider what we thought we knew about the universe's origins. One such challenge involves James Webb's baffling discoveries. According to current understanding, the first stars began to shine between 200 and 300 million years after the Big Bang, marking the end of the so-called cosmic dark ages. Yet the exact timeline of when those stars formed fully developed galaxies, and how rapidly they evolved, remains uncertain. Then came a breakthrough. In July 2022, scientists revealed that the James Webb Space Telescope had detected a number of galaxies, some dating back to just 300 million years after the universe's birth, providing vital clues in the quest to solve one of cosmology's greatest mysteries. In comparison to the massive structures that formed over the following millions of years, these early formations were significantly smaller and less massive, exactly as scientists had predicted. That made perfect sense. After all, the early universe simply didn't have a high enough matter density to form galaxies as large as the Milky Way. At least, that's what we believed, until a discovery changed everything. It all began with the detection of 6 faint, reddish points of light. What seemed like a routine observation soon sparked one of the most profound astronomical dilemmas of our time. Why? Because those tiny specks of light turned out to be ancient galaxies. And despite existing just 500 to 700 million years after the Big Bang, they were already nearly as massive as the Milky Way is today. Instead of finding the small, primitive galaxies scientists expected, the James Webb Space Telescope revealed massive structures that, according to current models, shouldn't even exist at that time. The finding was so astonishing that researchers at Swinburne University of Technology in Melbourne initially suspected an error in the data. But follow-up investigations confirmed the results. In fact, analysis revealed that these early galaxies contained over 10 billion stars, and in one case, more than 100 billion, with masses comparable to our Sun. This raised a troubling question. How could so many stars have formed so quickly when, by our current understanding, there simply wasn't enough ordinary matter available in the early universe to make it possible? These cosmic objects challenged nearly all existing cosmological theories, earning them the dramatic nickname universe breakers. To account for their existence, the early universe would have needed a matter density up to 5 times greater than what we've previously believed. Another, equally mysterious explanation suggests that these galaxies may have formed through a process completely unknown to us. But that was just the beginning, the start of the Big Bang controversy. The key point is this: the discovery of the universe breakers wasn't an isolated mystery. It was only the first in a growing list of baffling findings from the James Webb Space Telescope that strongly suggest our current cosmological model may be flawed. Webb has also uncovered ancient galaxies that seem far too evolved for being just a few 100 million years old. It's identified early supermassive black holes that are far too massive for their age. On top of that, elements were found in the young cosmos that, according to the Standard Model, shouldn't have existed yet. And to add to the mystery, Webb has confirmed the so-called Hubble tension, the observation that the universe is expanding much faster than theoretical models predict. It's becoming increasingly clear that our understanding of the early stages of the universe is far from complete. Some scientists even suggest that the real problem lies deeper, that perhaps the universe didn't originate from the well-known Big Bang at all. Even among those who still support the Big Bang theory, there's a widespread acknowledgement that this foundational idea raises many unanswered questions. Chief among them are the questions of why and how. How could something arise from absolutely nothing nearly 13.8 billion years ago? Is it even possible for anything to come from nothing? Was there a specific cause, or was it all a random occurrence? Renowned physicist Stephen Hawking addressed this directly, claiming that asking what came before the Big Bang is as meaningless as asking what lies north of the North Pole. Since time itself began with the Big Bang, the event couldn't have been caused by anything, or anyone, before it. Yet, this idea remains troubling to some scientists. Equally puzzling is the fact that the universe appears remarkably uniform in terms of radiation and matter density. No matter which direction we observe, the large-scale structure of the cosmos, galaxies, nebulae, and radiation, shows striking consistency throughout. Many scientists attribute this uniformity to cosmic inflation, a theoretical phase of incredibly rapid, exponential expansion that occurred within fractions of a second after the Big Bang. During this brief moment, the universe grew at an unimaginable rate. However, whether this inflationary phase truly occurred is still a topic of debate. Some researchers have expanded on this theory, proposing alternatives to the traditional Big Bang model. One such idea is chaotic inflation, which suggests that inflation didn't end everywhere at once. Instead, it stopped only in certain bubble-like regions, each potentially becoming its own separate universe. These bubble universes could have entirely different physical laws, meaning our universe might be just one small fragment in an infinite multiverse. Another fascinating concept proposes that our universe isn't unique at all. Rather, it may have emerged directly from a previous universe, suggesting a cosmic cycle of endless beginnings.